Okay, hello everybody. So today we are going to continue our discussion in Chapter 6, Section 6, and we're going to just try graphing a couple more of these inequalities. So hopefully you had a chance to watch the previous video where I explained what a linear inequality is and how to go about solving it. This video is just going to be a continuation of that and just to show you two more examples. So let's get started. So here in example 3, you can see we have two linear inequalities. The first is x is greater than or equal to 2. And I'm sorry, not 2. It's x is greater than or equal to 4. And then the second one says y is less than or equal to x minus 3. So the first one I'm going to go ahead and graph in red. And you can see that this is a special case scenario. So if you recall in the last one, we had a y is greater than or equal to negative 4. And that resulted in a horizontal line. And you can see that blue line down at the bottom. So when it's just y, it's going to be a horizontal line. When it's just x, it's going to be a vertical line. So this says x is greater than or equal to 4. It is a greater than or equal to, so that means it is a solid line through 4. So if I put a dot right on 4 on the x-axis, I can just go ahead and write a solid line through there. It does say x has to be greater than. So this is the only time that you will either shade to the right or the left of a line. Any other time, it's always up or down. But in this case, because it's a perfectly vertical line, we're going to shade to the right or the left. And it's really dependent on what it says. It says we want the x's that are greater than 4. So if we have a dot on 4, which we do, we want to shade to the side where the x's are greater. So that would be over here on the right-hand side. So we're going to go ahead and shade that with our red pen. Now the next one I'm going to do, I will do in blue, and that's more of a straightforward one. It's a slope-intercept form. So you simply have the b, which is negative 3, and then we would go up 1 over 1. You can do that a couple times if you want to give yourself a more of a line. Whenever you go to draw your line, you'll know where to draw it. Now this is also a strict inequality. This is less than or equal to. And so since it's a strict inequality, it will also be a solid line, just like you see there. The last stage to this one is to also shade it. So it says y is less than or equal to x minus 3. So less than, we put our first initial dot at negative 3, but we want to shade where the y's are smaller than that. And so that will be all the y's down here. So less than, just like that. And so what you see is the shading does overlap, and this area right here would be where the shading would overlap, and you would pull any solutions that you might want from there. Okay, so the last one I'm going to show you today is number 4. And this one's going to be a little different, and you'll see why here in a second. But go ahead and graph this first one. They're both in slope-intercept form, so they're relatively easy to graph. We're going to start at negative 7, which is down here. And then I'm going to go up 2 over 1, up 2 over 1. I'm going to do that a few times. It is a strict inequality, which it says y is less than or equal to. So that means it will be a solid line through those points, just like that. And it says less than. And so where we need to figure out where are the y's less than what we had there. And so that would actually be below. So that would be down here. All the y's are less than negative 7. Okay. Now the second one, we're going to graph it in a similar fashion. But the y-intercept for this one is positive 7, which is up here. And then our slope is going to be the same slope. It's up 2 over 1. And that should be your first indicator that something is going to be different about these. So I went up 2 over 1. If I went up 2 over 1 again, I would be off the coordinate plane. So I'm actually, from this point, going to go down 2 over 1, down 2 over 1. So I'm going down, which is negative, and left, which is negative, which keeps me on that line. It is a strict inequality, greater than or equal to, so I am going to draw a solid line on this one as well. But what I want you to see, and that one wasn't drawn that great. Let me see if I can do this a little bit better. That one's still off. Try third time's a charm here. That one's a little better. What I want you to see is that these lines are parallel. They are not going to intersect. We do still need to shade, and we want the y's that are greater than 7. So greater means we're going to be shading above this line up here. And what you're going to see is not only do the lines not intersect, none of the shading intersects either. And so this is one of the instances where there would not be a solution because there is not one ordered pair that would work for both of the inequalities. So that can happen. As a quick reminder, when you graph just linear inequalities, you could have them where they cross in one place. You could have them, whoops, why that did that. You can have them where they are two parallel lines, or you can also have them where they are the same line and they're on top of each other. So there's 3 different things that can happen with linear equations, systems of linear equations. But with systems of linear inequalities, there's only 2 things that can happen. Either there is an infinite number of solutions because the shading overlaps, or there are no solutions because the shading does not overlap. There is no one solution like there is for systems of linear equations. So in this case, there would be no solution. So there you go, guys. I hope that made sense to you. As always, if you have any questions, feel free to email me. Have a great day.